Welcome to This Explainer. Look, today we're diving into one of the absolute most remarkable transformations in all of enterprise tech. If you think you already know Java, like if you're still picturing it as that bulky legacy runtime just humming quietly down in the basement of corporate IT, well, you're in for a serious surprise. We're going to unpack how Java literally evolved into the central command plane for enterprise AI and exactly what that means for the systems you're building right now.
I want to start right here with this incredibly persistent claim. You know the one. It's the whole Java is dead tech obituary going around, claiming that AI agents writing Python or Rust are just going to make the language totally obsolete. It's a provocative hook, for sure, but man, it completely misses what's actually happening under the hood of global infrastructure today.
Okay, let's dive into this because honestly, this staggering number instantly debunks that myth. 73 billion. That's the number of active Java virtual machines running today, and 51 billion of those are operating in the cloud. AI agents aren't replacing this infrastructure, right? They absolutely depend on it. The transactional platforms, the heavy backend services, the data pipelines, they're already running on Java. The real question isn't whether to adopt Java for AI, but how we evolve the massive footprint that's already out there.
So, to make sense of this massive shift, we're going to break things down into 5 key areas: the JVM control plane, agentic architectures, security and vulnerabilities, the framework landscape, and finally, the economics of Java. Let's move to our first section and see how this builds. Section 1. The JVM control plane, Java 26 and beyond. So the release of Java 26 brought concrete features that basically turn the JVM into this governing control plane. And we're not just talking about abstract concepts here. We're looking at core enhancements, like JET 516, ahead-of-time object caching. That gives us blisteringly fast startup times. Then you've got JET 525, structured concurrency, which just completely simplifies managing the wild, multi-threaded code you need to coordinate multiple AI agent tasks all at once. These aren't just neat little tricks. They are strict execution obligations for the kind of scale that AI demands. Moving right along to Section 2, agentic architectures, bridging LLMs and the enterprise.
So the crucial point is how we bridge the massive gap between LLMs and your actual enterprise data. Enter the Model Context Protocol, or MCP. Think about it. An agent is really only as useful as the data it can securely connect to, right? Well, with Anthropic acquiring Stainless, which is the tool that generates these connectors at scale, and the rollout of the new official Java SDK for MCP, we finally have a standardized, secure bridge. This is exactly how your Java backend safely exposes proprietary data to an AI client without destroying your performance or totally blowing up your budget.
But here's the catch. The second you connect an LLM to your data, you instantly hit massive latency and API cost issues. We solve that using a tiered caching architecture. Check this out. For ultra-low latency internal state, teams are standardizing on caffeine. But to make sure an AI agent doesn't just suddenly lose its memory when a request hits a different node, we rely on distributed layers like Valkey or Readiness. And most importantly, to intercept natural language queries and stop those insanely expensive repetitive LLM calls, we're using vector similarity search for semantic caching. This entire tiered approach is what keeps your API budgets from absolutely exploding. Let's shift gears a bit. Section 3, security and vulnerabilities, the gritty reality of legacy code. Let me ask you this, to really put things into perspective. How does a highly secured, totally trusted system like NASA's Earth Data Platform get hacked using nothing more than a basic regular expression bypass? Well, it happened because of a fundamental disagreement between a string sanitizer and the actual XML parser logic. An attacker literally just dropped a simple new line character into a doc-type declaration. The regex completely missed it, the XML parser executed it anyway, and boom, a CVSS 9.1 server-side request forgery vulnerability that tricked the server into exposing internal AWS EC2 metadata. I mean, this is an absolute masterclass in why structural parser hardening is vital, and why Java 26's shift to integrity by default isn't just optional anymore. String sanitization just doesn't cut it. And this brilliantly illustrates a much wider, frankly terrifying problem we call zombie dependencies. Just look at this list from the May 2026 patch roundup. Even if your core framework feels secure, if you're running end-of-life versions of Spring Boot, your managed dependencies are actively accumulating massive vulnerabilities. We're talking critical sandbox bypasses in ThymeLeaf and literally private key leakages in Bouncy Castle. It is a massive, mounting mountain of security debt. The ecosystem is fighting back, though.
Looking just slightly ahead, JDK 27 is proactively integrating post-quantum hybrid public key encryption right into TLS 1.3. The whole goal here is to stop those harvest now, decrypt later attacks, where bad actors scrape your encrypted traffic today, just sitting around waiting for the quantum computers of tomorrow to finally crack it open.
All right, moving on to Section 4, the framework landscape, architecture as a strategy. So the industry has basically split into two philosophical camps at this point. On one side, you have the absolute giant, Spring Boot 4. It gives you incredible runtime flexibility and this massive tooling ecosystem. But, it comes with a much heavier memory footprint. On the flip side, you have Quarkus and Micronaut. Now, these are built around a container-first build time augmentation philosophy. They do all the heavy lifting before the app even starts, which makes them perfect for the serverless edge.
Now, what's really interesting about these numbers is the sheer scale of the performance difference. A cold startup in native mode for Quarkus takes 12 milliseconds. 12! And it demands less than half the baseline memory of Spring Boot. When you're out there orchestrating thousands of microservices or ephemeral AI agents on Kubernetes, that difference in memory density translates directly into massive cloud cost savings.
Which brings us to our final pillar, Section 5, the economics of Java, the bottom line. Listen, the era of blindly assuming Java is free is officially over. Back in 2023, Oracle shifted their licensing metric away from usage or processors straight to an employee-based model. That meant if you used Oracle Java, you suddenly had to license your entire employee base. Over the next couple of years, those hidden compliance costs really accumulated. And now, in 2026, we're right in the middle of the peak Oracle audit cycle. Java isn't just a technical choice for developers anymore. It is an urgent, business-wide financial liability that demands strict, top-down governance. Oracle totally knows this pressure is immense, and their direct response is the new Java Verified Portfolio, or JVP. It's built to give enterprise teams a highly governed single-source supply chain. They're throwing commercial support behind Helidon for your cloud-native microservices. They're actually bringing back commercial support for JavaFX so you can build heavy AI analytics dashboards, and they're even officially backing the VS Code extension. The strategy is clear. They want you securely locked right into their supported ecosystem. And honestly, the stakes for controlling that ecosystem have literally never been higher. The global market for Java web frameworks is projected to hit a massive $3.81 billion this year. So despite all the noise about new languages popping up, Java's economic impact and its entrenchment in the enterprise is actively growing, fueled pretty much entirely by cloud deployments and AI integration. So what does this all mean for you? Well, it completely changes what it means to be a developer in this space. Your role is shifting. Because AI assistants, like Copilot's new GPT 5.3 codex, can just generate boilerplate code instantly, your core value isn't about typing syntax out anymore. You are now an architect of context. Your job is to actually build the secure harnesses, the semantic caches, and the highly governed architectures that allow these autonomous AI agents to function safely and effectively within your company. So I want to leave you with this thought to reflect on when you look at your own tech stack. As the JVM fully transforms into the command center for autonomous AI, as the security landscape grows incredibly hostile, and as licensing costs demand absolute efficiency, are you actively architecting your contacts to leverage this future, or are you just paying a premium to maintain legacy code? Thanks for joining me on this explainer. I hope this gave you the clarity you need to navigate Java in 2026.